I'm Phil Jackman, Global Product Manager for Digital at Sun Chemical, and welcome to our session at FuturePrint.
Hello, I'm Simon Daplin, Product and Marketing Manager at Sun Chemical. Today we're going to talk to you about the life of an ink. We all know that the chemistry is an important part of the process, but how fundamental is it to making inkjet and the print work? We'll go through various explanations of why the ink choice is important, what to consider in the chemistry, and after the printing is finished, the next stage of life as the ink evolves into the product itself and how it must perform to ensure brand reputation and quality of product.
One of the questions that I'm regularly asked is, what's so special about an inkjet ink? And what I probably read into that is, what they're actually asking is, why does an inkjet ink cost more than an analogue ink? So I'd like to go and take a look at the building blocks of an ink and the extra effort that we put into manufacturing them to create the best possible performing inkjet inks for our customers.
So I think it's important to consider some of the inkjet fundamentals, things that make inkjet a little bit different to some of their analogue counterparts. So why they differ in consistency from their gravure or flexo counterparts, for example. So looking at the building blocks of ink and going right back to the beginning for the pigment selection and the techniques used to manufacture those, it's important to see why that is somewhat different. So in inkjet, it's more common to use high-grade performance pigments, sometimes for light fastest reasons, but a lot of the time is because it gives a better and more stable inkjet ink product at the end. At Sun Chemical, we're fortunate that not only are we the largest provider of inks in the world, but we're also a considerable player in the manufacture of pigments. So a lot of the pigments we actually make ourselves, which gives us the advantage to modify those during manufacturing to make them better inkjet products. So we can start to look at surface treatments of those pigments even at the manufacturing stage. And then making those pigments into a dispersion, so that's mixing them with some liquid chemistry so that they become a fluid effectively, but with dispersed particles in, so they are a concentrate of pigment that's able to be used for making into an inkjet ink. And these dispersions are different to what you would see for analog printing. I mean, the overriding factor is the particle size. In order to jet reliably, they must be small particles. So typical size is a few hundred nanometers. So all inkjet inks really are what you'd call nano inks effectively, if you're just measuring particle size. And they must be consistent. It's important to have the drops performing reliably, and to make them reliable, they need to be the same as all the other drops. So the same drop mass, the same size, etc. So they jet well. And also they must be stable. An inkjet ink must have these small particles of pigment dispersed in a manner that they do not regroup, they do not agglomerate, and they do not settle, which is somewhat challenging because of the low viscosity of the fluid. So already we've started to see some of the increased technical demands on inkjet ink even before we've actually made it into an ink. So when this gets into a print system, obviously the demands are somewhat different to analog printing. Fundamentally, this is due to the fact that you need to jet it, make it into drops. And these drops can be tiny. Typically, you're looking at 2 to 20 picoliter drop size. It can be more, but this seems to be quite common these days. And to put that into perspective, you're getting 100 billion drops out of your litre of ink. So this litre of ink that has to be very high technical performance, because it has to be broken down to so many parts to work reliably in terms of drops. And the rheology of that fluid is also paramount to the success. It's somewhat dictated by the printhead, the viscosity and surface tension, the working range of what really needs to be optimized for that printhead. And they must be consistent and homogeneous. Each and every drop should be identical in theory. Then you get perfect printing. But one of the things that is really key to success and reliability in printing for inkjet is nozzle blocking. Certainly if you took an average gravure or flexo ink and reduced the viscosity sufficient to jet it, it would have very poor performance in the print head, not only because of the particle sizes, but also because of the film forming resins that are used in there. They would effectively dry and block nozzles quite quickly. But this can be helped a bit with some of the architecture of the printing these days. The technology is maturing. The physical design of the print head has changed and improved over recent years. There's a lot of recirculation and also recirculation at the nozzle. So it keeps the nozzle area refreshed with new ink so that it doesn't dry. It just keeps it moving away past the nozzle. Software can assist by doing a similar thing, by purging, spitting and tickling the meniscus just to keep the area moving and keep it refreshed with fresh ink. But ultimately it comes down to the chemistry. The chemistry must really be able to be used in a manner that keeps the nozzles open and available to print. And this is where one of the biggest differences between analog and digital printing. But then to consider further jetting considerations, after the drop is born, it's still got a lot of performance work to do. It must form a good drop. It must have clean ejection. The way that the drops leave the nozzle is important. Shouldn't have hardly any mist, satellites or overspray, because this will impart themselves on the quality of the print and the image on the substrate. And the nozzle plate wetting is important as well, in so far as it shouldn't really wet them very much, so that you don't get pooling of ink on there that would hinder further jetting. So the relationship is complex between the ink and all the surfaces it interacts with in the print system. But that gets even more complicated once we reach touchdown. This little tiny drop has had its micro flight from the nozzle and then lands on the substrate. Here it must also perform in a very, very technically demanding environment in order to give the best possible result. So the spreading of wetting of a single drop on the surface is important, but also the way that it reacts with its neighbours, the intercolour bleed, printing wet on wet, colour on colour, drops side by side, and wanting them to behave in the manner that you want them to. And that means to sit still, behave, not bleed into each other, not spread unnecessarily, so that you get a nice quality of print. So here we can see already the very basic fundamentals of an ink, even before looking at the specifics of certain chemistry options that are favoured to certain markets, but just the overriding general principles of what is required of an inkjet ink in a printing system are certainly above and beyond what you would get from any other print process.
What is the life of an ink? That is the question that some people ask. And when they ask it, they're usually referring to the shelf life of the ink inside the bottle and how long they've got to use it. But the ink has a life that extends way beyond the print process. Many people, when they consider the life of an ink, will probably think, okay, it's about how you create it in the lab, what materials you use, how you mix it, what tests you do to make sure it's okay, does it jet properly, does it work on the printer, and then maybe about the evaluation of the print once it's happened. But there's fundamentally more things that the ink does and a life beyond the printing part that we need to consider. So fundamentally, most people think of ink life as a stable formulation, something that says, when I buy a bottle of ink, it's good to use for 12 months. They also expect it to print reliably, the life on the printer, that it doesn't damage the print head in any way or any of the other ink contact parts of the printer. So the ink life in terms of what it does inside the printer. Then there's its life in flight as it forms a drop and as it lands on the substrate, and what the ink does when it hits the substrate, how it manifests in terms of print quality. Is it producing the right color? Is the font legible? Can we produce very sharp images with good definition, good line sharpness, no blurring? But then there's the life of the printed article. After the print process is finished and all of the amazing inkjet processes have done their work, the ink still has a life on the product that's been printed. and that's critical. So it could be that you're applying it on a billboard advertisement where you need it to last for 4 weeks in direct sunlight and still be readable by the people passing. Or it may be in a food packaging environment where it needs to look good on the shelf, but it also needs to protect the food, or is part of that, and it can't do anything to fundamentally damage what's inside it. So we have to think about migration of the chemistry through the layers of the substrate and into the food, and whether that's something that happens or not, which leads into the print safety. So we consider that, or perhaps we're printing directly onto a food or pharmaceutical item where the product's going to be ingested, and it's critical that the materials are safe for consumption. Maybe we're printing onto baby clothes where skin sensitivity becomes a critical factor. And again, the selection of the chemistry and choosing the right ink becomes very, very important. And ultimately, we're all contributing to the brand reputation of the product that's been printed. More and more now, very few of us are able to go to shops in the environment that we're all experiencing today. So your first interaction with food or packaging from a supermarket is probably when you open your delivery to the door, and the first representation of the brand that you get is what you're holding in your hands, the product. And the first thing that you notice is the print. Is it the right color? Is it working in the right way? But also, has it scratched off? Has it smudged? Is there anything that the ink has done that may ultimately reflect on the reputation or the image of the brand? And more, that life of the ink is a lot more than just the printing process.
Here in the lab, we have a huge amount of materials that we can select when we're considering making an ink. But what's really important is we use the right ones for the right application to ensure the life of the ink extends beyond the print process.
So you can see that with that huge selection of materials, the ink is quite a complex chemistry, and it's a concoction of many, many different ingredients, all that have a purpose within the formulation, be it the color, removing foam, making sure the ink jets correctly, and all contribute to the onward cost of the ink, how the ink dries, whether it's compliant in terms of the application performance, and what's becoming a critical thing to consider in the modern day environment is its sustainability and impact environmentally. And that's something that we all must consider in terms of the ink selection and how we move forward.
In the lab, once the chemists have got a final ink formulation, we then test it for its characteristics in terms of its stability or shelf life considerations, how it may print, what the color might look like, and then what other application performances we need to test to ensure that the ink is doing its job as part of the final product.
So what does that mean practically when we say we have to look at the ink in the lab? Well, firstly, we need to go through some quality assurance to make sure that the ink is robust and fit for purpose, not just on day one, but throughout its expected lifespan as well. So we need to stress, we need to measure, we need to assess those inks. And there's various techniques that are employed here. Some of these are industry standard, but we've also developed some proprietary techniques that we use at Sun Chemical that we've learned over many decades of making inkjet inks. So we need to ensure the stability of these physical properties. So we look at the viscosity and surface tension, of course, but then also settlement. We need to measure whether these inks are prone to settle. As described previously, the importance of having small, well-dispersed particles and pigments is vital to the success of the performance of the inkjet ink, not just on day one, but also throughout its life cycle. So we measure this over a wide range of temperatures and times, and that can mean sometimes simply putting inks in ovens at various temperatures to do some accelerated age testing, but also going through things like freeze-thaw cycles to make sure that they're able to be shipped worldwide, and particularly during the cold season and winters, etc. So this is the way to measure and test the wet ink, and this is the starting point before you go and look at its print performance. And here you'll start looking at drop watches, so analysing the drops as they come out of a printhead, looking to measure and evaluate its drop mass, its drop velocity, looking at waveform development and seeing whether any satellites are being formed from the printhead as the nozzles are ejecting the ink. And then it's also useful to correlate what you see on the screen versus what you get on the printed surface. So being able to measure drops in flight with a camera system is useful, but then being able to quickly position that printhead and do some jetting with it and seeing whether that actually means what you see on the screen is what you get. And certainly this is a great way to measure and assess the printing and jetting performance. And then you need to do some assessments on the actual the printing of the ink in the particular printhead for the application. Firstly, just looking at some single colour rigs for some early evaluation. Here you can be looking for missing nozzles, trying to see how well the printing happens, trying to see any colour development, trying looking at dry time, early assessments, just for suitability. But equally as important here is reliability testing, making sure that when you print it, after 1 minute after cleaning, it remains consistent as 1 hour after cleaning. So you can measure open time and you can measure reliability performance here to ensure that there's no degradation in print quality. And then you can move on to multicolour systems, either single pass or scanning systems. This one's scanning. Here looking more for colour development, the CMYK drops, how they come together to form the beautiful images that you see in front of you. It's also good as a quick way to benchmark project suitability. For instance, a customer can send in some particular substrate material for evaluation, and here we can quickly apply 4 colours onto their chosen media and see whether it's fit for purpose, whether it meets the demands of that particular application. And also, again, reliability testing is important here. These machines have startup and shutdown cycles, and they have to work reliably in our lab environment as they would do out in the print shop with a customer. So we're able to measure and assess very quickly the performance of the inks in a practical environment.
In fact, the ink almost has several lives. In this case, the ink's life on the shelf is as part of the product, and its need to entice the consumer, have the right color and print quality to make the shopper stop and consider purchase of that item. So the ink is a fundamental player along with the whole printing process in attracting the consumer. But then if we consider its function in use, you see here 2 examples of the same product packaged differently, where in one case we're printing onto a label and applying it to a plastic bottle, and in the other printing directly onto a flexible pack or a pouch containing the same suit product. It's probably not the case that the same ink can perform the same role in both ways of packaging that product. So we have to consider always what's the life of the ink, what's the intended use of the product, how will the product be manufactured in order to understand what the right chemistry is to ensure the maximum lifetime of the product on the shelf and in the consumer hand. A similar example could be this, where we're in a performance sports or ski shop, and again, the first job of the ink is to entice the consumer, make the consumer want to pick up that product, the right color, that it's aesthetically pleasing and representing the brand in the right way. But then in the application, it takes on another life. It has to be light fuss, it has to be scuff resistant, fade resistant, water resistant. And fundamentally, that performance of the ink within the final product is what's defining the age and lifetime of both the ink and the garment itself.
When selecting an ink for printing, it's important to consider the final application uses or the nuances. What's different about that application? What are the specific needs that it has? So I have a few examples here of textile products that each needs a different functionality or performance.
So as you can imagine, during the lockdown period, there's been a huge boom in the sale of what they call athleisure or yoga pants, jogging leggings, that kind of thing. These are made of polyester, so typically they're printed with a sublimation product. The trouble with transfer sublimation is the dye doesn't always penetrate as much as you want. And what's important in a stretch product like this is that when it stretches, you don't see any white lines in the print, that you get a full black tone. You don't get what we call grin, where there's white lines as you pull it apart. So this has been printed with a direct sublimation ink to get that penetration and control without losing the integrity of the color or the image detail that you would expect from a digital print. This product, as you can see, is for ladies swimwear, and it's printed with an acid ink. And not only is it important that it looks good and the colors are nice and vibrant, but critically, it needs to have chlorine resistance, so that when it's used in a swimming pool environment, that the ink isn't destroyed or the color degraded by the presence of chlorine. An acid dye is able to do this. If we compromised and went cheaper or used a different process by using perhaps a sublimation ink in this case, or something not tuned to the polyamide elastane mix that's the garment's made of, you get a very different result and a product integrity that wasn't suitable. And finally, this is a product again printed with a sublimation ink. This is a Speedway Jacket, and you may think, well, that's not really a digital design, but in this case it's a short run production of bespoke uniforms for local speedway motorbike racing teams. And again, it's important here you have a fluorescent and a red color, so the identity of the team, the color needs to be highly visible. But of course, you can imagine the need for it to be scuff resistant, waterproof, wash resistant, and all those kind of things that you would expect from a performance garment. So getting the ink selection and the chemistry right is critical to the life of the product in the application it's being used for.
Of course, the life of an ink will vary enormously depending upon where that ink is printed and what is the final application of that end product. A few examples here. Here's a piece of laminated wood intended for furniture and flooring industries. Obviously the performance here is vital. It needs to laminate well, bond with the melamine, has to survive for many years, often over a decade. So the light fastness and wash resistance is very, very important here. Very unique properties for an industry. Maybe compare it to something like, industrial applications of printing onto mastic tubes, for instance. Obviously here it's about adhesion and it's about scuff resistance, and the application is somewhat difficult by the fact that the tubes are very slippery, and getting adhesion to these is somewhat challenging. Another industrial application, looking at printing on tins. This one's for some sort of varnish, so therefore it's not food contact. It's also a 3-piece tin, so it's printed flat on a sheet and then folded around and welded and stuck with the top and the lidding processes. Lots of physical properties going into sort of squeezing the ink and bending this around to make it into the final product. Comparatively, another metal application. This one's 2-piece beverage. Obviously, fundamentally it's ink on can, but it's also incredibly different in terms of the properties from an industrial product to a food product, and the fact that that's printed flat, and this is printed when it's already in a can shape. So there's different properties coming from the application space of what that ink must do in order to fulfill the needs of the brand owner, the end application, and ultimately the consumer. Moving again into some packaging environments, printing onto a pouch with inkjet. Obviously the challenge here is to make sure that it's food compliant, it's able to be printed in a way that it's acceptable quality, but of course being able to be laminated, being able to be folded and creased and sealed, and making sure that it's all compliant with food is of paramount importance. And the good thing here, of course, is Sun Chemical's such a big player in food packaging that we know these markets, we know these customers, we know all the applications. And of course, when all these products eventually get moved and shipped around, and certainly people these days are buying more things online and getting them delivered to their house, they'll come in a box. And of course, that's quite a boring box. These days you can print almost anything on demand, print an inkjet design, and then you can make everyone's lives a lot happier, having some colours. You can do some advertising. Point of sale in shops is non-existent at the moment, so it's getting more and more interesting to put digital print and digital advertising on the side of shipping boxes.
Customers and consumers have very exacting expectations when it comes to the ink and the chemistry. They expect it to print reliably, time and time again, with the same color output and the same quality of print. They expect it to be compliant with the different legislations of the application, but also that it's registered for certain countries that it may be used in. They expect the performance of the product to reflect the brand that they're printing for. So if it's a clothing item, they expect it to have a good wash fastness, good light resistance. If it's a food product, they expect it to be safe and not contaminate what's inside the packaging. And they also expect the level of innovation that drives them forward. We all are part of an industry that's moved on so much in recent years. And as print heads and printing systems evolve with faster speeds, the chemistry has to keep up to ensure that it's printing reliably, consistently, and meeting all the application requirements that are expected from the consumer.
So how do we meet these customers' expectations, especially given the aforementioned complexity and diversity that we see in the world of inkjet printing today? Well, please be reassured that Sun Chemical is one of the largest suppliers of inkjet inks and inkjet chemistry. We produce thousands of tons of digital ink every year, and it's a global business that we manage. And having the widest range of inkjet ink options available helps us serve all of our customers' needs. So therefore, we put those into many, many different applications. And 2020 was a strange year for everybody, but we certainly put our time to good use. We managed to start producing inks in Shanghai in China. You may have seen in the news as well the acquisition of the digital inks business from Sensient Technologies Corporation. This has really bolstered our commitment to the industry, grown our portfolio of products, and certainly grown our team of experts. We've also completed an office refurbishment in the UK within our digital business, and not quite yet completed due to some of the lockdown restrictions, but we have a new 2-story laboratory being commissioned in the next few months. So we look forward to being able to use this to further our commitment to the industry, both to enhance our support of existing customers, and we look forward to growing new opportunities with new customers too. Thank you for listening.